6.3, sine and cosine of graphs. Or sine and cosine graphs. You had this in Algebra 2, but it's been a while, so we review it again. We are only studying sine and cosine, then we pick apart. After you learn how to graph sine and cosine, then we learn how to translate them tomorrow. What does translate mean? Moving them, correct? Left, right, up and down. And then once you get the sine and cosine down, then I teach you tangent graphs. I do not teach you the reciprocal ones. What are the reciprocal ones? Secant, cosecant, and cotangent, right? If you feel like you're getting deprived of those three, you can look on the internet to figure out how to graph those three. So it's not that important. So okay, we're going to graph sine and cosine, and they end up being really long graphs. Do you guys remember this from Algebra 2? When you graph sine and cosine graphs, in order to complete one complete cycle, you need, put up here, 5 points. You remember this from last year, 5 points. One is already at the origin, and then I put four more out there. One's at the origin and 4 more, and try to be equidistant. And then up 1 and down 1, up 1 and down 1. Okay, this whole chapter is on radians, so we're going to work with radians. So basically, I'm going to make this 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And I'm going to use this little chart to help me graph what a sine and a cosine graph looks like. Okay, you notice that there's a spot at 0, a spot at 90, a spot at 180, a spot at 270, and a spot at 360, correct? But instead of saying those, I'm going to say that this is 0. The first one's going to be 90, but I'm not going to say 90 because this whole chapter is in radians, so I'm going to say pi over 2, which stands for 90. Instead of 180, I'm going to say pi. Instead of 270, I'm going to say 3 pi over 2. And all the way back around is 2 pi. And I'm going to do the same thing down here. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so all I'm going to do is look at this little chart that we learned in the last chapter. And I'm going to look at sine first. What is the sine at 0 degrees? Isn't the sine this value right there? Right? So at 0 degrees, isn't the answer 0 at 0? At 0, the answer is 0. At 90, which is pi over 2, isn't the sine the y value or 1? So at 90, I'm going to go up to 1 and put my dot. At 90, I'm going to put my dot at 1. Now I'm over here at 180, which is the same thing as pi. What's my y value? 0. Back down again. Then I'm down here at 270. What's my y value at 270? Negative 1, which is down here. And then back up again is 360 or 2 pi. And if you connect these, they're supposed to be curvy. They're not supposed to be like connect the dots and make them straight. They're supposed to be curvy. See the curve? It's supposed to look like waves. Oceanographers, sonar, they have to study these. Oceanographers study this. They watch the tide go in, the tide go out. Sonars deal with this type of graphs. Math teachers, yeah, I don't know what else. Don't ask me anything else. Just know about 3 or 4 things that deal with wavy curves. I'm like a doctor? Or no? What is that? Monitor. Does that do that, or what is? I don't even know what it.
Those are straight lines.
Right. Okay. They're more like. You're right. They're more cornery. They're more like this, aren't they? No, you don't want that to happen. No. Okay. Anyway. Okay. So this is more sonar. This is more tide waves, right? Okay. Do you notice that if I keep going, if I put another slash here? If this is 360, if this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, wouldn't this spot be 5 pi over 2 if I keep going? Wouldn't this be 5 pi over 2? Could I keep this going? Would this go back up again? Would it just keep going forever and ever and, you know what I mean? So, this is a continuous graph. Continuous, it never ends. All I want on the test is only 1. What does 1 mean? Start here, and once you start repeating is all I want on the test. A sine graph kind of makes a small little hill and a small little valley is pretty much what a sine graph looks like. If you want to give me more than 1, you can give me more than 1, but all I want on the test is 1. Okay, the next one, what does a cosine graph look like? We're going to do exactly the same thing, except we're not looking at the y values, we're going to be looking at the x values, correct? So what is the cosine at 0 degrees, which is right here? The cosine is 1. What's the cosine of 90? 0. What's the cosine of 180? Negative 1. Cosine of 270, 0, and 2 pi again is 1. And where did I got those? It's all of my x values. When you connect the dots, it's again curvy. I missed my dot there. You see the difference between a sine graph and a cosine graph? A sine graph and a cosine graph. This little guy looks like a reindeer. You see the reindeer, you guys, from last year? Remember driving the reindeer? See the little eyes and the nose and the little antennas. Anyway, we did this last year. I don't know, second semester, I didn't have a lot of you, so maybe you don't remember my little reindeer. So, okay, but does this continue like the sine graph? Could it keep going back and forth and so on? All I want is the beginning of 1 and the end of 1. Okay, here's some things. These are both periodic graphs. What does periodic mean? Repeats. These are both periodic graphs and they both repeat. And all we're doing is let you know what the period is for a sine and cosine graph. They're exactly the same. It's 2 pi is the period. What does 2 pi mean? 2 pi means 360. That means it takes 360 degrees before it starts repeating itself, right? And this is going to change as of tomorrow, 6.4, when you start moving it and shrinking. So the only thing we're doing in 6.3 is getting used to recognizing a sine and cosine graph. Sine starts at 0, cosine starts at 1. Okay, I just talked about really quick, if this would have been a negative sign, do you know what happens to the graph if it's a negative number? Yeah, it still starts at 0, and it would look something like this, wouldn't it? Wouldn't it look like that? Instead of starting at 1, it would start at negative 1, and it looked like that instead, correct? So, okay, moving along. They want you to refer to the graph cosine of 7 pi. I just want you to do what you did yesterday to do this instead. Just instead of referring to the graph, just do what you did yesterday. Don't use your calculator. Get used to knowing that. What does this stand for if you only get to there? How many is that? Pi. How much is this one? 2 pi. 3 pi, 4 pi, 5 pi. Most of you know that 7 pi will land on an odd number, right? Which is right here. Isn't this a negative 1 comma 0? We kind of did this yesterday, but we're doing it again. What is the cosine of that point? It's the x value, which is negative 1. Final answer. Again, we did this yesterday, so this one should not take long. Hopefully you just get done with your homework pretty quick today. They want you to do the sine of a negative 9 pi over 2, right? A negative 9 pi over 2. You need to know what pi over 2 stands for. Do you guys remember what pi over 2 stands for? 90, but we're going in the opposite direction, right? So are you guys ready to go? Here's 1 negative pi over 2, right? Isn't this 2? Isn't this 3? Isn't this 4? 5? 6? 7, 8. You see how you can do this really quickly just by counting. So what's the sign of a negative 9 pi over 2? Sine is the y value, which ends up both being -1 for the answer. And that's it. Kind of a repeat from yesterday. Does somebody want one more? I can make up another one. I can make up, obviously they're going to land right on the axis. So no more? Moving on? Okay, next part. Find all the values of theta. They want you to find now, if they give you the answer, you have to find the what? What does that stand for? If they give you the answer, you're finding the angle, right? You're finding the angle. Okay, here's the key word in part 2. The word all. Find all the values of theta. Ready to do this? And it becomes tricky. So, where is the sine of theta equal a -1? I'm just going to go back to the first page. Sine of theta equals a -1. Here's my sine graph. Where is your graph at a -1? Isn't it at 3 pi over 2? Right? Right here is where your angle. So, you're going to put 3 pi over 2 down. This is called the inverse, right? When you have to find it. But that's not the answer. It says to find all the values of theta. The word all. So how do we come up with this? Go back to this graph. Do you notice that there's one answer right there? It's got a little arrow going to it. Do you notice that there's another one right here? Do you notice that there's another one right here? Do all of these angles hit -1? Right? So what do you write down if they want all the answers? Would you be here forever? Could this go hit the wall out the door? Could it go across the street? Could it go across the railroad tracks? You know how long it would take you to list all of the -1s? So instead of listing them all, you're going to say, wait, I'm going to look to see where this repeats. How long does it take to repeat? How long does it take to repeat to get to the next dot? 2 pi, right? Doesn't it repeat at 2 pi? So, in order to get the right answer, you're going to say the first time is 3 pi over 2 plus a whole bunch of 2 pi k or x or whatever variable you want. So what's 3 pi over 2? Let's say k was 1. Would that be the next dot? What happens if k was 2? Here's the first dot was down here. Isn't the next one when k is 1? Isn't the next one when k is 2? Or let's say we want to go in this direction. How do you get this one when k is -1? When's the next dot? When k is -2. Instead of listing them all, you list them like this. Okay, where is your sine of theta equal to 0? This one's trickier. Where is your sine of theta equal to 0? So go back. Where is your sine of theta going to equal 0? At what degrees? 0. Laura might write down 0. Kaylee might look at it and say, well, my first time, my eyes went to here, to pi. I don't care where you figure it out. 0, pi, how about 2 pi? Could you put 2 pi down? Okay, so you can write down any one of those answers on the test. You can write 0. What's the other one? Pi. Another one, 2 pi. You can use any one of those as the answer, but is that the final answer? Nope. You're going to add something to it. And this is where it gets a little harder. Go back at this one. You notice that at -1 it repeats after every 2 pi. Do you notice that? But look when 0 repeats. 0, pi, 2 pi. Obviously this must be 3 pi. What's the period in between the zeros? Pi, right? So instead of writing 2 pi, you're going to put pi k, or whatever. I don't know why they use the variable k, but they do. You understand? If they want all the values on the test, make sure you add pi k to it, or 2 pi k to it. You can use x, you don't have to use k. And you can use any one of these depending on where your eye ventures to first. Got it? Okay, next part. I think we only got one more part. Yeah, graph. So, they want you to graph this. This one's easier than this one. They want to see if you already have this side memorized. You know it takes 5 including this. You know cosine starts at 0 and it looks something like this, right? Equal to 2 pi. But if you look at the stipulation, they only want you to graph it from where? They want you to graph it from a negative 3 pi to 0. So this isn't the graph they want. They want you to follow the stipulation. So if this is pi over 2, what is this slash over here called? A negative pi over 2. If this slash is going to be called what over here? What is this slash going to be called? Negative pi. This slash is a negative 3 pi over 2. This slash is a negative 2 pi. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This slash is going to be a negative 5 pi over 2. This slash right here is going to be a negative 6 pi over 2, which is a negative 3 pi. They could care less about them this way. They want from here to here. They want you to graph it using the stipulation that they give you. So if you start here, where's this one going to go? Is it going to be up here? Are you going to put it here, or are you going to put it here at negative 1? Where does it go? It starts here at 0. Where would negative pi over 2 go? Here, here, or here? 0. What's the next one? Where would the negative pi have to be if you're making a cosine graph? Down. What about here? Up. What about here? Up. What about this one? Down. What about this one? Down. Final answer. What did I make? I made a full graph. Everybody see the full graph? And then a half of a graph. Because I'm following what they're asking me to graph, right? Following the stipulation. Okay, this one, sine of theta is 5 pi to 7 pi. Again, I'm going to start looking at my graph. I know that this is pi over 2. I know that this is pi. I know that this is 3 pi over 2, and I know this is 2 pi. And I know that every sine graph starts at 0, goes up, goes down, and comes up. So it looks something like this. You need to know that. You need to memorize that. What? You guys need to memorize that the sine graph always starts where? 0, and a cosine graph always starts at 1. You need to know that. Yep. They want you to graph, they could care less between 0 to 2 pi, right? They want you to graph what? 5 pi to 7 pi, right? But doesn't sine and cosine graphs always repeat each other? So let's figure out, let's go back to, let's just look at this. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Isn't 5 pi an odd number, right? So I'm just going to make a little line like that and just say, here's my 5 pi. And then my 7 pi needs to have 1, 2, 3, 4, and then my 5th one. Did I do that wrong? No, this is my 5th one. 7 pi. I'm going to graph from 5 pi to 7 pi. In between there, what does that make? 5 pi to 7 pi? 2 pi. So is that periodic, right? So I know that this is what my graph looks like. Could I continue all the way out and put 2 pi and then 3 pi, 4 pi and keep looking to see what it does? But instead, I'm just going to look at my pattern because I know that it's, if this is 1 pi, isn't 1 pi a negative 1? Isn't 3 pi also a negative 1? Isn't 5 pi also a negative 1? So at 5 pi, I should be down here at negative 1, right? And if 5 pi is a negative 1, isn't 6 pi, isn't 7 pi also a negative 1, right? And you know what a is this a sine graph? This is a sine graph. So if this is, I just did cosine, sorry. I was thinking it was cosine. Start again. I was thinking that it was, did I do that one right? Yes, cosine start. Okay, sine, start again. Is sine 0? Sorry, sine is 0 at 5 pi. Sine is 0 at 7 pi. So can I make my sine graph between 5 pi and 7 pi? Do you know what it looks like? Does it look like this? I don't even know how to do this. Forget it. I'm not going to even make up anything. It starts here. Where's my next dot going to go? Up or down? See, well, you know this one's back here at 0, okay? So you need to decide, is it here, or is it here, or is it here, or is it here? You know, it could be doing this part first, right? Out to 5 pi. But if you look at pi, isn't pi an odd number? What's it doing at pi? It's going down. So if this is odd, isn't it going down and then going back up? That's an odd number, right? It's not going up because of the pattern at all the odd ones are starting down first, and this is an odd one because 5 pi is odd. So instead of going up, it's going to go down. So this is the end of one of them, and this is the beginning of the other one. Do you guys get that? That this is the end of this is the end, and this part is the beginning of a new one. You get that? That's the end of one and the beginning of the other. So, and what you're supposed to be doing is kind of looking at that there's a pattern to this. Do you notice at 3 pi that it goes down first? So if you get to 5 pi, it would also go down first. Got that? Okay, so what's the assignment? There isn't much to it. 19 through 36 all. And you have a half an hour. You should easily finish this, 19 through 36. Because there isn't much to this. Tomorrow, though, we're going to translate. And that's where it gets more powerful. So. '19 through 36, I'll put it on the board, page 364.